Hello, everyone, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover securing applications with OCI security services, the solutions that are available today, what's planned next, some advantages, and how easy it is to get started. And now I'll hand it over to Gautam to begin today's session. Thank you.
Thank you, Brandon, and welcome everyone. I appreciate you joining us today. Let me start with a brief introduction. My name is Gautam Mishra, and I am a security solution specialist at Oracle. And as part of the cloud engineering team, I work closely with customers to help secure their workloads and applications on OCI. So today, our focus will be on best practices and strategies for securing applications within OCI. And I'm pleased to have my colleague Amit Chakravarti here with me as well, who is also a key member of our team. I'll hand it over to Amit to introduce himself as well.
Hi everyone, this is Amit here, Amit Chakraborty. I'm a solutions architect focusing on cloud security, including identity, governance, network security, and architecture. I advise customers and help them design and implement security solutions on the Oracle Cloud Infrastructure platform. Thanks, Gautam.
Thank you, Amit. So, as you can see on the agenda, today's session will focus on three core services within the OCI security portfolio that are essential for protecting your applications. So, we'll be covering Web Application Firewall, Certificate Service, and API Gateway. So, each of these services will play a critical role in delivering a comprehensive and a layered approach to secure your workloads on OCI. And by the end of this session, you will come away with a clear understanding of how to leverage these services in order to enhance your security posture, whether it's protecting your web application with WAF, or securing and managing your APIs with API Gateway, or effectively handling your certificate lifecycle with certificate services. To make these concepts more tangible, we will also be showcasing basic demonstrations throughout the session. So these demos are designed to give you a practical insights that you can start applying right away in your own environments. So with that, I'll hand it over back to Amit, who will start by covering Web Application Firewall and Certificate Management Services on OCI.
Thank you, Gautam. So let's look into WAF and how it can help you in maintaining a secured environment. So what's the use case here? Where does the requirement come from? Why WAF? Let's look into the classic use case of accessing a web application. Here, you have a web app deployed on VMs or OKE in a private subnet, front-ended by a load balancer on a public subnet for HA. The user accesses the app, which responds with the results to the user. This is a happy use case, but note that no one is inspecting the traffic, whether the requests have any attack payload, which geographies do they originate from, etc. So enter the bad actor. It has a free pass and starts injecting malicious payload. Now that's a problem. That's why you require a WAF, which will inspect requests and block or allow traffic as required. So the customer benefits using OCI WAF are: you have a layered defense and flexibility to enforce security in region closest to the application on flexible load balancers, protect applications from malicious and unwanted internet traffic, and being a native OCI service, it uses OCI IAM policies for control plane access management. And it also, for the logging purposes, it is integrated with the OCI logging service. Now, OCI WAF has three important features: access control, protection rules, and rate limiting. The OCI WAF acts as a reverse proxy that will inspect all traffic flows or requests prior to these arriving at the origin web application. It will also inspect any request going from the web application server to the end user. This is very powerful and will allow you to inspect egress traffic from your application servers as well as protecting your servers from outside threats. Now, you can use the access control rules to restrict or control access to your web applications. As an example, WAF ACLs can be used to block countries from getting to your application servers. For example, if you don't do business with certain countries, you can completely block access from these countries. You can also activate the access control rules based on HTTP header or URL addresses. The OCI WAF is a cloud-based WAF that supports about 490 rule sets, including the OWASP rule sets. Use these rules to protect your critical web applications against malicious cyber attacks from bad actors. These rules are compared against incoming requests to determine if the request contains an attack payload. If it determines that the request is an attack, the WAF will then block or alert that request. These attacks are many and varied and include threats such as SQL injection, cross-site scripting, HTML injection, and many more, all of which can be detected and blocked by the OCI WAF rule sets. Rate limiting is often employed to stop bad bots from negatively impacting a website or application. Bot attacks that rate limiting can help mitigate include brute force attacks and the DDoS attacks. Being a native service of OCI, its logging is integrated with the OCI logging service. Now let's look into the WAF demo, but before that, let me walk you through the console and check out the various WAF features we discussed so far. So here you have, I'm having a WAF policy already defined. It's called the Amit apps here. And as we went through the slides, these are the three important features: the access control, the rate limiting, and the protections. For example, for the access control, as you can see, I have already defined two access control rules. So in this case, this particular rule says that for any request which you are actually fetching, which you are trying to actually get hold of the objects from the web server, as long as, for those GET requests, as long as the URL, the path actually starts with /test, the action is going to be allowed. So any other request which you are trying to actually use with GET, while getting that request, any other request with a GET, if they don't start with the /test, then this particular rule is going to actually block it, okay? Because there is no matching, and therefore this WAF is going to actually block such request. Similarly, I have actually defined another rule, a corresponding rule with the post verb. But these are not the only ones. For example, you can actually go and try to add different types of actual conditions depending upon your use cases. For example, I had created the two rules with the path, but you have other other ways, other scenarios you can actually consider. For example, you can actually use the request cookies, any kind of HTTP headers, the URL query instead of the path, the country region, for example. So in the country region, if you don't do business with certain countries, you can actually list those countries over here, and you want to absolutely block those countries, you can actually select those countries. And then in the rule action, you can actually, basically say block. So in that case, if requests originate from those countries, you want to absolutely block them. So then WAF is going to actually detect those country regions, the origin of those requests, and it is going to actually send a 403 forbidden. Now, this is something which I have already configured a rule action for blocking. You can actually use any other 400 kind of error codes, status codes. So this gives you a lot of it's a very powerful mechanism with the ACS, access control rules, and you can actually craft rules according to your business use cases. Next, let us actually look into the protections. As you can see, I have already defined multiple protection rules, and there is this particular rule, Amit Web Apps, and this is the one which I'm going to actually use it in the demo. It says that when the host is amitwebapps.oci.com, then all this set of actually rules which are essentially 4 protection capabilities, they are going to actually come into play. Now let us go into more detail. For example, if I try to look into the production capabilities, as we discussed when we were going through the slides, we discussed that there are about 490 rule sets, and those are the capabilities which you can actually get with the WAF, and it covers practically lots of cases. For example, it can actually help you to mitigate attacks from basically a SQL injection kind of attacks, cross-site scripting attack. This is a kind of actually attack which I'm going to actually show in the demo. The PHP injection attacks, the remote code execution attacks, the RCs. There are flavors for the Windows group, for the Unix group, the local file inclusion, and there are a bunch of other rules. For example, this particular rule which says there's missing user agent. So it detects if the request is actually missing the user agent header. This is very typical of the bots, which are essentially scripts, and they kind of actually bombard the attacks, the requests, and many a times they don't actually have the user agent. And so this is kind of, this particular rule actually thwarts, such kind of attacks which don't have the user agent. Now, as you can see, there are multiple such actually rule sets. You can actually, basically choose the categories, the groups of rules which you want according to your use cases. As you can see, OCI WAF actually provides, rules, production capabilities, and the rules for different types of actually CVEs. For example, this particular CVE is related to this RC attempt, and so on and so forth. And along with that, there are OWASP specific rules like the OWASP A3 2021, A5 2021, and so on and so forth, the A10. So these are the rules which are essentially classified. They belong to the OWASP categories. And with each of these rules, you will have the various tags, and as you can see that for this particular rule, this has the OWASP 2021, tag. So this way you can actually build your list according to the primarily according to the tech stack of your web application server. So for example, let me go back to the recommended ones. So out of the box, OCI WAF actually gives you a set of rules, protection capabilities. They are clubbed together as recommended, and you can actually use it as a starter, and if as for protecting your web application. But but it is very comprehensive. Now, depending upon your tech stack, you can actually add to these recommended set, or you can actually remove. For example, the RC ones, as we just now saw, there are two flavors here. One is the Windows and one is the Unix, right? So if your tech stack, if your web application, in the back end, the one which you are protecting, if it is essentially a complete Unix, your landscape is completely Unix, you don't have any kind of actually Windows boxes at all, then there is no point in actually including this particular rule. Okay, so that is one thing, and vice versa. If yours is actually essentially a Windows, and you're pretty sure that your tech stack doesn't include any kind of actually Unix, you don't need these the Unix-based rules. And similarly with the PHPs. So it all depends upon what kind of actually collaborative, what kind of tech stack you are having. And going back over here, you will the kind of actual protection rules which OCI WAF gives you pretty varied. They are based on applications, like Confluence and Grafana, and Jakarta, Apache Jakarta, and so on and so forth. There are categories on the databases also, like the MongoDB, MS SQL, Postgres, and so on and so forth. On various types of actual language-based, protection rules, Java, PHP, JavaScript, etc. Platforms, Docker platform, Apache platform, and so on and so forth. So it's very, very comprehensive, and depending upon your tech stack, what you are actually using in your backend servers. OCI WAFs gives you a whole set of a full gamut of actual protection capabilities which you can use to protect your applications. So this was about the protection capabilities, and we will see some of them in the demo. And then finally, it is the rate limiting. And as you can see, I have actually defined a few rate limiting rules already. So for example, this particular rate limiting rule says that if the request limit from that origin, from that client, is more than 60 in a second, in a minute, which is 60 seconds, then this particular rule is going to actually will fire and actually basically block subsequent requests for the next 60 seconds, that is a minute. So that way it can actually bring down the request, the rate of incoming requests, and that's where the bot attacks can be actually thwarted. So these are the various three types, as we said: access control, rate limiting, and the protections. Finally, once you have actually defined the WAF policy, you have to attach it to an enforcement point. And today we support load balancer as an enforcement point. So here, as you can see, that I have already basically attached this particular policy to this enforcement point, to this particular load balancer. So if I go to this load balancer, which is gadget IPU v4, you will see that the web application policy is already attached to that. So that is how once this attachment is done, a firewall object is actually created, and the firewall object, from the firewall object, and that's when the incoming traffic starts actually getting inspected. So as part of the demo, now as you can see that I'm trying to actually access or the root document of this particular website, and I can see that this request was blocked. And again, just to actually reiterate, basically we had this particular rule allowed URLs with get, and this particular rule says that allow the traffic, all the guest request, where the request actually starts from the /test. In other words, this rule is going to actually stop it. So in this case, you are trying to access the root document, right? So it is not actually starting with /test. So WAF actually kind of actually blocks. Similarly, this is the other request in which I have actually sent a script, and it's a malicious kind of script. So I have actually sent a script as part of the query with this particular request. Now note that this particular request, it starts with /test. So this access control rule should actually pass, and we will see that that is indeed the case. However, the protection rules, this is the Amit Web Apps. This is the protection rule which comes into the force because of the condition called amitwebapps.oci18.com, and that is the site which I'm actually accessing, right? And if I go into this protection rule, I have actually 4 of them, and 4 rules, 4 protection capabilities, and one of them is about the cross-site scripting, and I would expect that this particular request to get blocked by the WAF, and indeed that is actually happening. So how do we know that this is actually, we know that it is working, so but we can actually correlate with the logs, and as you can see that in this case, if I go to the WAF logs, I'm seeing that the request, when I actually expand the request, I'm seeing that I'm basically accessing the root document, and you can see the response provided is the default action, and it sends the default code as 403 as expected. Similarly, for that other one, where I'm actually sending the request, with the /test with the script, that is this particular request, which is getting blocked, you will see that this is also getting blocked. But the match rule for the access control allowed URLs with get, and that is working fine. that is working fine, and that should be the case, because that's what we are actually saying, that this particular rule, it says that, oh, you have actually sent a GET request but with the /test, so it should match, and that's what it has actually, the logs says that the request access control rule looked into it and said that yes, it has matched, and I'm actually letting it go. However, the request protection now is actually flags it. It said, oh, I found a script with the alert, this, and it is the matched ID is 944941110, and the rule says Amit Web Apps. So if we go back and look into the protection rules, Amit Web Apps is the capability which got the rule set which got actually came into the action. And if I go into this particular expand it, I see that 94410 is the cross-site scripting. So this gives you an idea how the OCI WAF can come into play and basically protect your web applications from malicious bad actors. So this is the demo I wanted to actually show, and so that kind of actually concludes our presentation on the WAF. So let me switch back to the deck, and let's move to our next topic, which is certificates, and let's look into the certificate service. Integration with OCI load balancer lets you seamlessly associate a TLS certificate issued or managed by certificates service with resources that need certificates. API gateway integration is also similar. Integration with OCI IAM identity and access management lets you control who and what services can access which CAs, certificates, and the CA bundles, and what they can do with those resources. OCI audit integration gives you a way to monitor certificate usage. Audit tracks administrative actions on CAs, certificates, and CA bundles. Certificate service, it supports private CA. A CA typically contains other CAs with defined parent-child relationships between them. The CA at the top of the hierarchy is known as the root CA. The intermediate CAs within the hierarchy of such entities that issue digital certificates are subordinate CAs. You can create such a chain of trust with CA hierarchies up to 10 branches deep. You can select from RSA keys that are 2048 bits or 4096 bits. You can also select the ECDSA keys that have a curve ID of NIST P384. Specifically, the list includes only these types of asymmetric keys that are protected by a hardware security module, HSM, in OCI Vault. Certificate service, it doesn't support the use of software protected keys in OCI vaults. It publishes the certificate service. It publishes revocation list, that is the CRLs, automatically to object storage and allows for custom formatted URLs. Custom formatted URLs provide the URL that you want to use with APIs to access the object store object. This URL is named in certificates as the CRL distribution point, that is the CDP. Now let's discuss some use cases for private CA. First, if you have a controlled environment, you would like to, say for example, you would like to manage the entire lifecycle of certificate authorities, including the root CA, private CAs from OCI certificates will be perfect for this use case. Second, you can use private CA for lower environments such as dev, test, etc. Finally, for the mutual TLS cases, MTLS, you can use the private CA. Now, there are three ways you can create and manage certificates. You can issue certificates and manage them internally by CA. The use cases can be controlled environment, lower environments such as dev, test. Second, you can create and submit a CSR, and the CA from the OCI certificates can issue a certificate The private key and the certificate will be managed externally. MTLS use case is an example of such usage. Finally, you can import certificate created externally by, say, Let's Encrypt. And use cases, can be the production environments. So let me actually walk you to the console and check out the various certificate features we discussed so far. So here, this is the landing page of the certificate service. And as we saw, we can actually create different types of actually certificate services. And over here, you can see that I have already created a root certificate and 2 subordinate certificates. And for example, if I go to the sub CA1, you can see that issuer sub certificate authority was that root CA1, and this certificate authority itself has actually created the sub CA2 here. And it has also created some certificates here. Certain certificates are issued by internal CAs. Some of them are actually issued by internal CA but have been managed externally, as the MTLS use case we have seen. So in this way, you can actually create a hierarchy of such certificate authority, a hierarchy of such CA authorities, the CS. Second, we can actually look into the various certificates here. I have, as you can see, I have actually a bunch of them, and the one which I will be actually showing in this particular for this particular demo is the certificate called the Amit Web Apps OCI18.com. If you look into the subject information, this certificate is essentially issued with the name to the amitwebapps.oci18.com. And this certificate is essentially an imported type. I had actually used Let's Encrypt to create this certificate and then import it over here. And then what I did is that, as we saw when we discussed in the slide, the certificates can be actually integrated with the load balancer. And that's what I have actually done. In fact, for my WAF use case, where I was actually using, I was actually using the certificate which in the certificate service, and then basically integrated that with the load balancer. So if you see over here, this is the certificate, the amitwebapps.oci18.com. It has been issued by Let's Encrypt. So there's a public CA, and it is of the imported type. So this is what this certificate has been used. There are other, you can actually renew certificates. This is going to expire in September. So I can actually renew. Once I actually go to renewal, I have to upload the certificate. Once I get a new certificate from Let's Encrypt, I have to actually basically upload it over here. And there are other types of certificates which we talked about. The 3 types which we talked about. One is the imported, one is what I showed you right now. There are the second category is the issued by internal CA but managed externally. This is what you will be doing. Say, for example, over here, if I go into this, this is the one which you will be doing for the MTLS, mutual TLS use case. So here, in fact, under the certificate, if I just actually go 3, you see that these are the 3 ways you can actually do it. Import it from Let's Encrypt. And over here, if it is issued, just say test here. And if I actually move to the next one, you don't need that. And if you go here, you see that, you have to basically just upload the certificate signing request, the CSR. So you create the CSR externally, and then you upload it over here, and the certificate service is going to actually create a certificate for you, and you can download that certificate. You already have the private key, because that's what you use for creating the CSR. And then you, with that private key and this newly issued certificate, you put it into your client server for the MTLS, the mutual TLS handshakes go on. So that is another one. The third type is actually a pure issued by internal CA. We talked about that also. So these are the 3 types of actually CAs. Now, talking about the association, let me just show you some association over here. As I was saying, that this is the certificate which I have actually used in the load balancer, and it says that yes, it has been associated with that load balancer. And if you actually go to that particular load balancer, you will see that I have actually landed in gadget IPv4. And this is exactly the load balancer which I used for the WAF use case. As you can see, this is the Web Application Firewall. Okay. So that kind of that concludes our presentation on WAF and certificates. So Gautam is now going to discuss about the next topic.
Thanks, Amit. So now let's discuss API gateway. So as the name suggests, right? So API gateway acts as a central point for all your APIs, right? Regardless whether they are hosted on OCI or on on-prem or even on any other cloud platform. So, okay, I have the poll results. Okay, so this service will allow you to securely publish the APIs with the private endpoints accessible within your network, or if needed, expose them to the internet with the public IP addresses as well. So the service will offer the flexibility and the control which are needed in today's multi-cloud environment that probably supports the Oracle's commitment to seamlessly interoperability for different platforms. So as the API gateway is a serverless fully managed service, so it g- goes ahead and provide regional high availability and disaster recovery by default. So when you create an API gateway, the service automatically deploys into multiple instances across different availability domains within that region. And if your region has one availability domain, the service distributes instances across all available fault domains in order to ensure resilience. The API gateway instance operates within your chosen virtual cloud network, and if it is deployed in a public VCN, your API gateway is accessible via public endpoint on the internet. And conversely, if deployed in a private VCN, it is accessible only to applications within your VCN, provided that correct security list and network security groups are configured. And it also supports custom domains, which allows you to set up vanity URLs for your endpoints. So by default, the instance is assigned to a domain like, say, oci.customer-oci.com. But you can create custom URLs such as application api.customer.com in order to suit your branding needs. So the service is available across all the OCI regions, including commercial, government, and the dedicated region environments. And it also supports stock responses and client SDK generation, which means that, say, if your backend application is not ready, you can use API Gateway to return, say, pre-configured responses, enabling front-end development uh, to proceed independently while your backend is still being built. And from the networking perspective, since the service runs in customer VCN, customers can use all the security controls of VCN like security list or network security groups in order to protect the API gateway instances. It also support service gateways as well. So if you have service gateway deployed in your VCN, API gateway will use service gateway to connect to other OCI native services. And from security perspective, it is protected by OCI IAM service. So you have to write IAM policies to allow your control plane users to be able to manage or perform CRUD operations on API gateway instances. And the service is integrated with the OCI certificate service as well in order to manage the certificates for your API gateway instances. And it also support mutual TLS. So if you have a requirement to support client certificate validation as well for your API gateway instances, the service supports that. And you can obviously build custom trust stores as well for the backend API endpoints. As a as I mentioned in the beginning, API gateway acts as a gateway to your APIs, and on that gateway, you can enforce certain security policies to protect your backend APIs from, say, malicious usage, or sort of block this request at the gate instead of letting them hit your APIs and probably affect performances of those APIs. So from enforcement perspective, it supports all these sort of methods. So the first one is OpenID Connect and OAuth support. So it can act as a proxy or gateway to your APIs and enforce OpenID Connect support for legacy application that does not support modern authentication protocols. So what you can do is you can put API gateway in front and have it enforced modern authentication, and then configure trust between the API gateway and the backend application in order to support the legacy authentication. And the way you would do is by writing custom authorizer function where all those logics for authentication can be written, and then access token can be sent further to invoke application in the backend route. It does support rate limiting as well, which is how you did see in WAF, as Amit showed you. So you can configure how many requests you want to allow per client, or say per endpoint, and API gateway will enforce that as well. And you can use that to support your billing as well. So let's say you have an application, and depending on the subscription type, you want to allow X number of API calls in a minute or probably in a second. So you can use those data in order to enforce rate limiting for those different types of subscribers. It does support request validations as well, where it can look into incoming request headers, and if it has any malicious headers, then it can block those requests. One very common use case is blocking requests with basic authorization headers, because I've seen most customers that do not want to support basic authentication, and you can use API gateway to enforce that restriction as well. It supports request response transformation too. So, uh, which means that wherever you can, you can transform the request and response headers to add some additional headers, or remove, or probably append more information to those headers, and you can do all those sort of manipulations on the API gateway. And it does support dynamic routing as well to your backend APIs. Since it's a fully managed and OCI native service like WAF, and OCI certificate service, like it easily gets integrated with your OCI's observability and management platform as well. So what that gives you is audit logs. So if anyone tries to do any crude operations on the API gateway that is on the control plane, then all those control plane requests on the API gateway instances are logged in audit logs. It does integrate with OCI logging service as well. That will help you to capture your API gateway instance data plane log. So once API gateway instance is created and API clients start hitting your APIs, all those could be captured in OCI logging service. And there are two types of logs emitted by API gateway: access logs and execution logs. Access logs will basically tell you that someone tried to access the APIs in the backend route, and execution logs will show you when those APIs were hit and what did API gateway actually did. It gets integrated with monitoring service as well. So wherever you can see all those metrics, like uh, what actually API gateway did. So you can see what was the response time, how many requests were received, how many were successful, or probably how many of them were failed, and if they failed, how many of them failed with, say, 4xx responses, or if they failed with the 5xx responses. And you can take all those logs and send it to logging analytics to provide you a detailed analytics out of those logs, where you can create all sort of dashboards or capture all sort of requests hitting the API gateway, and get a detailed view of the response time or say failed request as well. So you can even ship those logs to your preferred enterprise SIM solution to view those data and have a relevant analytics out of those data. Now let's talk about some of the real world use cases which we can actually perform using API Gateway. So the first use case is where you can leverage API Gateway to kind of serve as a secure entry point for APIs that are accessed over public internet and connect to backend services like virtual machines or serverless functions, object storage, and data integration resources. So a typical use case could be using the API Gateway for cloud native applications like Oracle Integration Cloud. So I have seen most of the Oracle Fusion customers build their integrations using the integration cloud, where they actually want to protect or enforce security for those Oracle integration cloud APIs, and they go ahead and put API gateway in the front. Another use case of API gateway could be like, let's say you are running a data center exit program and some of your applications have already moved to the cloud and probably some are still running on-prem that needs to get accessed by the one which are there in the cloud. So you can put API gateway between the applications running on the cloud and the ones which are there on-prem and route all those requests from OCI to the on-prem applications. Another use case is, let's say you are running application modernization program and you have moved your application to the cloud, but you know that due to time crunch or like you were only able to modernize some applications and the rest are still sort of legacy applications which probably continues to use legacy authentication like basic authentication or say custom authentications which were explicitly built for those applications. And as all the modern applications would then prefer to use protocols like scheme or JWT tokens, you can put API gateway in front of those legacy application, have it support modern authentications, and then use the custom authorizer function to sort of create the tokens that the backend application will understand or will accept to do any other request transformation as well, like uh, before hitting the actual backend applications. So that is again one of the very common use cases of API gateway on OCI. Now let's look at some of the demo here. For the first demo, I'll go through an use case for which we helped a customer some months back, where the customer actually wanted to invoke Oracle integration cloud endpoints using Microsoft Entra ID's access token. So to do this, we can we used an API gateway deployment with a custom authorizer function, and the process starts when a user obtains an OAuth token from Microsoft Entra IDs, which actually serves as a proof of identity. And then using this token, the user calls an endpoint exposed by the OCI API gateway. And then the API gateway, which is configured with the custom authorizer function, forwards the token to an OCI function which is designed to validate it. The function performs token introspection by communicating with Microsoft Entra ID to confirm the token's authenticity, and then generates an OCI IM token for additional downstream calls to invoke the actual backend service, which is the Oracle Integration Cloud endpoint. And finally, the response from the OIC, it gets relayed back through the API gateway to the user, completing the secure access workflow. Now, let's see that in action. Let me take you to the UI and show how we did it. So we'll look at my API gateway here. As you can see here, Azure token is my API gateway deployment, uh, which uses the authorizer function as the authentication type. and I have my custom authorizer function selected here, which is a single argument function, authorizer function, where only an auth token can be passed to the function. And also the parameter has been specified for the incoming requests token header name. So the function has the logic in place. So it actually will go ahead and assess the incoming enter ID token, and then what it does an token introspection and then decodes the token to grab the UPN value, and then uses that UPN to generate an user assertion, and post that generates an OCI IM token scored for the integration instance. And behind the scenes, when my Azure integration endpoint is invoked, it's actually calling the actual integration cloud endpoint and does all those header transformation by setting the backend token from the authorizer function in the authorization header. Let me take you to the Postman now. This is where I will hit the token endpoint on the enter ID to generate an access token. So I'll hit send and I'll copy the access token, and post that I will hit the endpoint, which is the backend to the API gateway deployment. I will paste the previously copied access token from enter ID and then hit send. So the API gateway, what it actually did here is it invoked the authorizer function, did all those checks, and then hits the backend endpoint and gives a 200 OK response. With this, we'll move to a second demo that I want to show. This is how API gateway enforces modern authentication like OpenID Connect for one of my backend applications that actually do not support any modern authentication. So to do this, so this is my another API gateway deployment, and you can navigate to the definition of the API gateway deployment and then choose the authentication type which you want to support. So here I have selected OpenID Connect authentication, and I want the API gateway instance to invoke the introspection endpoint of the authorization server. And here I have mentioned the discovery URL of my authorization server, and also the client ID and the client secret, which will be used to connect to the authorization service. And I can also configure that I want to enforce PXE for my OpenID Connect authentication. And I can also configure the API gateway to use cookies for the session so that the application side sessions can be maintained by API gateway, and you don't have to redirect API gateway clients for OpenID authentication for every single request. Now let's see this use case in action. So I'm hitting my API endpoint here, which should redirect me to the OpenID Connect server. So on this login page, I'll provide my username and I'll provide my password. And upon successful authentication, I should be logged into my backend app. And to show you the session cookies, okay, yeah. So the browser actually goes ahead and stores the cookies which were generated by the API gateway. With that, we have reached the end of our session. So thank you for your time and participation. So here are some of the key resources that cover all the three services which were discussed today. So please go ahead and take a look and explore this at your further convenience.
All right. And if you enjoyed this training session, feel free to join us for some of the upcoming webinars. We do have, a hands-on series for day one and beyond. We have our security series, which we're on today. What's new in OCI? Did you know series? That is coming up on the 22nd, so next Monday. And then on the 23rd, we are conducting our AI chatbot hands-on lab. So if you're interested in any of these, please join our sessions and we'd be happy to have you. Thank you all for the time today.